Hello, welcome back to another video of Math Today. We're on the 24th video. Today we will be using our knowledge of exponential functions to understand compound interest. Let's get into it. First, let me explain what simple and compound interest is. Let's say you're investing money in a bank and you put $100 into it. Every month, you will gain 1% of that $100. So, the second month, you'll have $101 because you're adding 1% of 100 onto 100. Then the third month you'll have $102, and on the fourth month you'll have $103, and so on. This is called simple interest because every month you're gaining interest on your initial value, which is 100. Now, let's say you invest in a second bank and you put $100 into the bank. Every month you gain 1%, but that 1% compounds. Let me explain. For your second month, you will gain 1% of 100, so you'll have $101. On your third month, you'll gain 1% of 101 instead of 1% of 100, so you will then have $102.01 or $102.01. For the fourth month, you'll gain 1% of $102.01, so you'll have $103.03. This is called compound interest because every month your interest compounds onto the new value instead of gaining interest only on the initial value. As you can see, the second bank with compound interest slowly gains more money than the first bank. I even have a graph to show you. The red line represents compound interest and the blue line represents simple interest. Compound interest quickly skyrockets while simple interest is at a fixed steady rate. Now, let's analyze a real-world scenario with compound interest. Let's say you have $1,000. You're going to put this $1,000 into a bank that gives you a 5% interest rate. This interest will compound yearly. You decide to keep your money in the bank for 10 years. We want to know how much money you'll have after 10 years. To make this easier, let's make an equation. This won't be an exponential function format, but it will be similar. First, we have to determine the principal. We will call this P. This is the amount of money you start with, or your original investment, like your initial value. This means our principal is $1,000, as you can see here. That's the amount of money that we put into the bank. Now we need to know our interest rate. We will call this R. We already went over this earlier, and it is 5% or 0.05. Then we need to know how often your money compounds. We will refer to this with the letter N. This would be yearly. Now we have to find the growth factor. We will write this as 1 plus the rate or the interest rate over how often your money compounds, or N. So your growth factor is going to be 1 plus R over N. This tells you how much your money is compounding each compounding period. Let's say instead of our money compounding yearly, it compounds monthly. We would then write this equation as 1 plus 0.05 as our interest rate over, instead of every year, we're going to do 12 for 12 months because it's monthly, and this is about equal to 1.00416. This means we would earn about a 0.42% interest every month if we convert this into a percentage. Now we have to figure out the total time, or T, we have our money in the bank, as well as how many times we compound over that time, and we can refer to that as NT. We have a total time of 10 years, so I'll write 10 right here. And to figure out how many times we compound over 10 years, we multiply how many times our money is compounded over a year, which is 1, by our total time, which is 10. So NT would just be 1 times 10, so we still have 10. This means we will compound our money 10 times over the whole time span. Lastly, we need to identify our output or final amount, A of t. To do this, we must put all of our parts of this equation together. First, we take our principal, which is 1,000, and we multiply this by the growth factor, which is 1 plus 0.05 over 1. We're going back to every year. And we raise this to the NT power, so we're going to raise this to the 10th power. Now we would have A of t, which is our final amount, is equal to 1,000 times the quantity of 1 plus 0.05 over 1 to the 10th power. Now, let's figure this out. This can be written as the same thing as 1,000 times 1.05 if we just calculate this whole part in the growth factor together to the 10th power. 1.05 to the 10th power is about equal to, here let me just write this, is about equal to 1.6288. Now, if we multiply 1,000 by 1.6288, we get 1,628 and 89 cents. I actually forgot to add a 9 right here. So 1,000 times 1.628889 is going to be 1,628.89 cents, or 89 cents, if that makes sense. This means that after 10 years of investing in this compound interest bank, you earn $628.89 and end up with $1,628.89. So this is, oh, my arrow looked terrible. This is our answer, $1,628.89, and you'll earn about $629. This is it for Math of the Day today. Next time, we will find Euler's number. I hope you enjoyed this video and learned something new. Thank you for tuning into Math of the Day today. Goodbye.